If a ship of aliens came across this object floating in space, what would they think? From the big mirror, they might guess it was a telescope, built by a curious species for taking pictures of the universe. But they couldn't know that it took 10,000 people from 14 countries 20 years to build it. Or that it was designed to look for the beginning of time and space. Until it started looking for them.
Telescope anyone's ever built. One of our reasons for being is so that we can do these good and interesting things that move us forward as a species. I think everybody wants to be a part of something greater than just what they can do alone. Building something like the JWST is that.
It's amazing for me as an astronomer to work on this project. JWST is the next huge step in furthering our understanding about the universe. It's almost like there's a curtain beyond which we can't see. The telescope is going to allow us to lift up that curtain.
This is a telescope to help us understand who we are and how we got here, and the big picture of how did it all come to be.
For thousands of years, people thought the Earth was in the center of the universe and everything revolved around us. But in 1609, the astronomer Galileo raised his homemade telescope to the sky and found evidence supporting the idea that we're actually going around the sun. We've come a long way since Galileo, and telescopes have gotten more and more advanced. We now know that the sun is an ordinary star in a galaxy we call the Milky Way, a spiral of 200 billion stars, so big it takes light 100,000 years to cross it. Until now, the most powerful space telescope was the Hubble, and it found more galaxies than we ever knew existed. Some of them are so far away it took their light billions of years to reach us. The universe began with the Big Bang, 13.8 billion years ago. This was the beginning of time and space, and it happened in an instant. For a short time, the universe was only made of hydrogen and helium, and it glowed like a warm campfire. Then, for several 100 million years, there was nothing to see. Slowly, under the force of gravity, tendrils of material began to coalesce, and the first stars and galaxies shone forth. We've never seen them, but they must be there.
How do the stars grow from that primordial material? How do the galaxies grow? It took a few 100 million years maybe for the first luminous objects to occur. The first stars, the first galaxies, the first black holes, whatever it was. So our idea, one of our most challenging projects for this new telescope, is to look for those first things.
We wouldn't have built the telescope this big unless we needed to, and you need to build a telescope this big if you want to look at the very dimmest, most earliest galaxies in the universe.
The mirror is 6.5 meters or 21 feet in diameter. And the problem with a mirror that big is it wouldn't fit in a rocket. So they had to build it in lightweight segments and figure out how to fold it up. The earliest, most distant galaxies in the universe can only be seen in infrared light. Infrared light is heat, and to detect it, the telescope must be kept very cold. It must be completely shielded from the sun, and that was a whole different kind of problem.
We don't want the telescope portion to see any of the sun, so this sun shield is a really good SPF. It's about 1 million. What was particularly challenging is the fact that we have to fold it up and deploy it once we get on orbit.
It's an engineering marvel. The sensitivities and the requirements for doing the science correctly are so difficult that one would say it may not be possible.
The telescope was originally set to go to space as early as 2011, but things kept going wrong. The cryogenic cooler for one of the instruments failed. The sun shield developed tears. And at times it looked like the telescope might never make it to the launch pad.
When you accelerate from 0 to 17,000, 18,000 miles an hour, things can go wrong. So it's that constant thought, did we think of this? Did we think of that? Did we think of this? Because the slightest thing that could go wrong could actually mean this mission could fail.
Until very recently, the only planets we knew existed were the ones in our own solar system. But then, exoplanets, planets around other stars, were discovered. Thousands of them. And a new generation of astronomers realized they could use the telescope to study them.
With JWST, it started as this pure kind of idea for the cosmologists. They were going to look at the first ever stars that were born. And exoplanets muscled our way in to become one of the primary science goals of the telescope.
Most exoplanets are discovered using the transit technique. When a planet crosses in front of a star, the light dips by a tiny amount, and we know it's there. JWST is so sensitive it can detect the elements in the atmosphere of a transiting exoplanet by the way the light changes as it passes through that atmosphere. If there are elements necessary for life, the telescope could detect them.
As a kid, hearing that we were at this frontier of being able to search for life or signs of life made me feel like there was no other question worth answering. We're hoping that JWST is successful so that we can actually get some really astounding observations of these planets' atmospheres.
By the time the telescope was ready for the 6,000-mile journey through the Panama Canal to the launch pad in French Guiana, it had cost $10 billion. And NASA and its partners, the Canadian and European space agencies, were counting on it. Failure would be a disaster.
Good morning and Merry Christmas from the Guiana Space Center in Kourou, French Guiana.
It's a laser focus here in the control center as we get closer to launch.
I watched the launch from my mom's couch in Bee Branch, Arkansas, rural Arkansas, middle of nowhere. It was really beautiful. The Christmas trees over in the corner, and it was, a typical Christmas morning, except that we were all glued to the TV, and I was on my laptop communicating with the team. I've been on this project for 14 years, and so I think all of us, as much as we trusted the engineers, all of us were a little on edge, or maybe a lot on edge.
NASA officials, including Rick Robinson, carefully watching the telemetry.
More than 10,000 people, all different disciplines, made Webb possible. They're ready to go, and I'm ready to go. There's always a feeling of holding your breath at launch. The butterflies are strong once we see fire from the ground.
So launch is shocking. Now you're lit, right? In this explosion, right? That has to get you in orbit.
It's the most violent environment you can imagine. We felt the ground shake, felt the building shake and stuff like that.
Space Telescope Science Institute, their work just beginning.
About 45 seconds into that video, you see this thing deploy, this accordion panel.
A bit earlier than planned, but there is the solar array.
And we were never supposed to see that.
There it is. There's your critical call. The telescope not only has legs, but it has power.
The shocking thing for me was seeing that solar panel. We didn't expect to see that. It was waving goodbye.
This will be humanity's last view of the telescope as it moves to its workplace about 1 million miles away from Earth.
Now comes the riskiest part of the mission. Over the next month, the telescope must fly to a location called L2, 4 times farther than the moon. On the way, there are more than 300 deployments that must go perfectly for it to work. They're called single-point failures.
Single-point failure literally means if one thing goes wrong, you fail. There isn't a backup, there isn't an alternate. A dozen would be a lot. And we had 344.
Okay, just want to confirm you see first motion?
I can confirm first motion.
Copy, just give us a status as we move on down through the movement.
OC, you are go to fire.
Whitman's go. All stations, this is Mom on Ops. We're go at this time to finish Sunsteel tensioning.
Every hinge that has to move, every cable that is going to deploy a sun shield that's going to pull it out, 90 of those single point failures. If one of those didn't work, it literally could have been the end of the mission, and we just could have floated out into space as space junk.
Same thing I am. We have the primary mirror at this time.
With the concur.
And we have a fully deployed JWST observatory.
We have a telescope in space. We've just unfolded the telescope. When I was 10, I was in a field. It was late at night. My mom's coming out to look for me, and I didn't answer her, and I was laying on my back looking at the stars. I was looking at satellites crossing the sky, and my mom said, "What are you doing?" She got on her back. I said, "You see that? Those things that are up there?" I said, "I want to fly one of those." I'm flying one of those now.
A million miles away in its cold orbit out at L2, the telescope now turns its golden eye to a tiny sliver of the sky, no bigger than a grain of sand held at arm's length. It's looking past the stars in our own galaxy into the emptiness of intergalactic space. It stares for 6 hours, the detectors collecting light from the distant universe. What it sees is beamed back to Earth in a series of ones and zeros over the deep space network.
Good morning, everyone. We are live, and this is it, the moment we have been working towards for 2 decades, the reveal of the first science images from the James Webb Space Telescope.
Okay, we've got the whole world watching. Are you ready to put the first image up? Oh, let's do it.
When the telescope stared at that dark sliver of the sky, it saw this.
So the first image is a deep field.
Except for a few spiky stars, these are all galaxies. They're all sizes and ages and colors. The deep field was designed to be a test of the telescope, and it was working better than anyone imagined.
All those dots that you're seeing are not stars. The majority of them are galaxies. Cities, each one with about 100 billion to 300 billion stars on its own.
The brightest galaxies are part of a cluster 4 billion light years away. The light we see from them took 4 billion years to reach us. It left those galaxies around the time our solar system and the Earth itself was forming. But these aren't the farthest things we can see in this picture. Far from it.
The other thing that's extremely incredible is that the universe is providing us an even bigger telescope.
Little arcs, strange-looking little arcs, curved things that don't look like anybody else's galaxy at all.
What you're actually seeing is the effect of curved space. Space like between you and me, where the geometry doesn't behave itself.
This is called a gravitational lens. Einstein said it should happen. He thought we'd never be able to use it for anything, but he knew it could exist.
A telescope is a time machine, and JWST is the most powerful one ever built. It can see deeper into the past than any telescope in history, revealing a hidden part of the universe. Galaxies glowing in infrared light from soon after the Big Bang.
There's a bunch of little red rubies all throughout the image. Oh, there's one. Okay, yep, they're here. Yes, this is going to work.
This picture is just a few pixels across, but it's a snapshot of the infant universe. And imagine being in the room when the telescope first beamed back what it saw to Earth.
This is what I get. It's a black square.
The image is there.
The image is here, but I just have to pull it out. The brightest regions are the only things you can see in here. So these are like the cores of galaxies and the bright stars in the image. And then as I bring it up, more detail starts to show up. I was just like, I can't believe I'm the first person in the world to see what this is going to look like from Webb. And it was incredible. I just couldn't believe what I was seeing. It was a very moving moment, actually, when I pulled myself out of the pixels and actually looked at the whole image. It was incredible.
The images emerging from the darkness reveal a whole new universe. an infrared universe, invisible to the human eye. This group of galaxies is called Stephan's Quintet. They look calm enough at first glance, but JWST's infrared cameras capture what's really going on. 3 of the galaxies are crashing into each other in slow motion. They're colliding and merging. As they're torn apart, tails of gas and dust whip through space in torrents of fire. Looking farther into the infrared reveals something very strange. Glowing at the center of one of the galaxies is an enormous black hole. It's 24 million times the mass of our sun, and it creates a dent in space where gas and dust tumble in. The material circles faster and faster, emitting energy and light before disappearing into the darkness. Other telescopes, like Hubble, took pictures of galaxies. But JWST reveals their structures in intricate detail. Hubble saw the Cartwheel galaxy, but JWST can see the energy radiating outward like ripples in a pond from a collision that happened long ago. Hubble saw the Phantom galaxy, but JWST reveals its skeleton. Clumps of gas and dust where a new generation of stars is forming. In the Tarantula Nebula, the telescope sees stars actually being born. They're still shrouded in the dust of cosmic birth, but infrared light goes through the dust, taking us into the stellar nursery for the first time. The telescope can see the beginnings of stars much closer to home.
This image, yeah, this is the one that made me cry when I first saw it.
Astronomers call this place the Cosmic Cliffs because it looks like a craggy landscape on Earth. But really, it's a vast cloud of gas and dust being blown into this shape by the bright stars above it. They're young stars that have recently been born. The cosmic cliffs are in our own galaxy, only 7,600 light years away, nearby compared to the distant universe.
This one's part of our story. This is how stars are being born. Our sun came from something like that, about 4.5 billion years ago. Stars like the sun with planets around them are being born as we watch. Stars can die in there, and the circle will start again. So that's one of the enchantments about this place. These really bright stars here are so hot, they're burning off the surface of this cloud. And see the wispy stuff is coming up like steam off a pond in the cold winter morning. It's being vaporized by the heat of these bright stars. And a picture like that, it's just incredible details. There's things in there nobody's ever seen, ever. And they're features you can't explain. And there's a thing that looks like a hook in there. Well, why has nature got a little thing that looks like a hook? No, I don't know. We'll find out. The picture is so different from what you can ever possibly imagine because it's so beautiful.
It's so beautiful. Like I'm almost I'm almost tearing up now because it's just.
So when you see it, what is it that's so beautiful to you?
This has always been there. It's always been out there, but we're just now able to see it. We now have this new telescope that's opened up our eyes to see something that we couldn't see before. I once was blind, but now I see.
The telescope has shown us how stars are born, and it also shows us how they die. When the fuel in the core of a star starts to run out, it becomes unstable. The star at the center of the Southern Ring Nebula is blowing off gas and dust in an enormous bubble that expands at thousands of miles an hour. And JWST found this star on the brink of a more dramatic end. It will soon go supernova, exploding in a fireball that can outshine the entire galaxy. This is the remnant of a supernova that could be seen in 1667, not long after the time of Galileo. The star is now gone, but its material has been blown into interstellar space, where it will be incorporated into new stars and planets in a cycle of birth and death and rebirth. The elements that made our sun and our Earth, and us too, were born out of exploding stars like this.
Our atoms are immortal, and we have been recycled.
We are recycled.
We are just recycled. We are recycled. It's okay.
We are the product of multiple generations of stars exploding and casting that matter out into space. And then that matter gets sucked up into the next generation of a gas cloud that's collapsing and forming a new star.
You know, you look up at the night sky and everything seems so distant and far away, but that's our origins. That's where we came from.
And this is one of the richest places new stars are being born in our galaxy. It's called the Pillars of Creation. The Hubble telescope took this picture in 1995, but it couldn't see through the dust. JWST sees right through it. The stars are formed when the gas collapses under the force of gravity, compressing into spheres that get hotter until nuclear fires ignite in their cores. This is a star just emerging from its cocoon. It looks a little like E.T.'s finger. And in fact, this is the touch of life.
Star formation is how we get the heavier elements. Atoms are literally crushing together to form the oxygen that we breathe, and the iron that's in our blood, and the calcium in our bones. It all came from a star.
We are made of stardust. The nuclear fires in the cores of stars and supernovas make the heavier elements. These elements become clouds of dust in the spiral arms of galaxies. We've seen clouds of stardust before, but only JWST captures them like this, drifting in the cool vastness of interstellar space. The instruments identified ice grains here that contain carbon dioxide, methane, ammonia, even water, the building blocks of life. The telescope took this picture of a new star system forming out of interstellar clouds of gas and dust. In the center is a line of material that spins as the star is born, the protoplanetary disk. The disk of stardust is the realm of new planets. Some will be gas giants like Jupiter, and some will be rocky like Earth. This is how our solar system formed 4.5 billion years ago. The telescope now turns to our own backyard, revealing new details about our planetary neighbors. The rings of frozen Neptune glowing in infrared light. Uranus, the only planet in our solar system, tilted 90 degrees on its side. Astronomers think this may be from a collision with another object in the distant past. Saturn, with its famous rings, and a few of its 146 moons. Astronomers hope to find more, maybe even in this image. Jupiter, shrouded in clouds of frozen ammonia and methane, and its moons that Galileo saw 400 years ago. And then there are the asteroids.
Control system settling down, angular rates look really good.
The protoplanetary disk left behind millions of rocks circling the sun.
Looks to me like we're headed straight in.
A big one hit the Earth 65 million years ago and wiped out the dinosaurs.
Oh my goodness, look at that.
This is a video feed from DART, a probe NASA sent to try to deflect one of these asteroids.
Oh my goodness. 8,
Yeah.
7, 6,
Wow.
4, 3, 2, 1.
By studying the explosion, the telescope and observatories around the world found that the path of Dimorphos had been altered. Now we know that if an asteroid is headed our way, we might be able to do something about it. The Earth is an oasis in a vast universe. In spite of all we've seen, it's still the only place we know there is life. The atmosphere of our world, with its delicate mix of oxygen and carbon dioxide, and its surface of water and rock, has made life possible. Could there be another living planet out there?
Are there any other planets like ours out there? Is there water, liquid water on the surface of another planet? Because that will be the first signpost of life.
JWST now turns to gaze at a star 1,300 light years away. Orbiting around it is a planet called WASP 17b. A team of exoplanet astronomers is finally getting some data back from the telescope to analyze.
So I'm gonna reveal the spectrum that we've got now. We are seeing very clear evidence of CO and water in the atmosphere.
The telescope detected water vapor in the atmosphere of WASP 17b, but this is no place for a vacation. It's known as a hot Jupiter. It's so close to its star that the planet is 1,700 degrees and the water is scalding steam. The team also identified quartz crystals and sulfur dioxide enveloping the planet in a thick fog. We won't find life on WASP 17b, but soon the team will be looking at another system entirely. 40 light years away lies a star system called TRAPPIST-1, with 7 Earth-sized planets around it. Unlike WASP 17b, the TRAPPIST planets are not made of gas. They are rocky, like the Earth. The planets closest to the star will likely be too hot to keep an atmosphere, and the farthest ones will be frozen solid. But there are 3 planets in the middle where liquid water could exist.
TRAPPIST-1 might be the best system that we will uncover in terms of being multi-planet, in terms of having all the vacation spots you can think of. Very cold planets, very hot planets. TRAPPIST-1 is pretty unique.
Pushing the telescope to its limits, the team is trying to detect an atmosphere around TRAPPIST-1e. An atmosphere hasn't been found on a rocky exoplanet yet, and it would be a big leap forward in the search for life.
The universe is so big, you know? I think there's no question that we're not alone.
There's just so many possibilities that statistically, I mean, you can decide for yourselves.
I'd take that bet in a heartbeat.
Are we the only planet where this happened? Are we totally alone?
Yeah, I think there's life out there. Can we find them? I think we will. In my lifetime, God, I hope so. Because I want to know, you know?
Where did we come from? How did the universe begin? Are we alone? We've always wondered these things, and now, at last, we're getting answers. This telescope has transformed the night. We're close to seeing the beginning of time and space. We're close to seeing first light. We know there are as many as 1 trillion galaxies, each with hundreds of billions of stars and more planets than grains of sand on all the beaches of the world. We've always been a lonely species, floating in space, wondering, hoping, wishing, longing. Surely somewhere in the deep sky, there's another living planet, just waiting to be found. Any day now, we may find it.